For topic 2, we're going to define rational exponents of the form a to the m over n. So this is a little bit different. In the previous example, the exponent was 1 over n. Now the exponent is m over n. Okay, so the definition. If the nth root of a represents a real number and m over n is a positive rational number such that n is greater than 2, then a to the m over n equals the nth root of a to the m power. Okay? First, take the nth root of a and then raise it to the m power. Now, similarly, we can have another situation that shows up here. If the nth root of a represents a real number and m over n is a positive rational number such that n is greater than 2, a to the m over n can equal the nth root of a to the m power. So notice the parentheses versus not parentheses. These two expressions are the same. It just kind of depends on how you want to simplify it. In this case, you first raise a to the m power and then take the nth root. I think usually this first version right here, I find this can oftentimes be a little bit easier because you're taking the nth root of a smaller expression and then raising it to the m power, but just play around with it because sometimes one version will work and the other won't, but these are the same. So these two things are the same, okay? So let's look at example 2. Example 2 just says simplify, okay? So we have 16 to the 3/2 power. Remember, the denominator is the index. The numerator is the power, okay? So here we're dealing with an index of 2. So that tells me I've got a square root. So I have the square root of 16, and I can raise the whole thing to the 3rd power. And in this case, I think this is easier, and I'll show you in just a minute why. So we already know that the square root of 16 is 4. So this is really just 4 to the 3rd power, or 64. Now, I like this first version first, where we take the nth root of a and then we raise that whole expression to the m power, because if we had done it the other way, we would have the square root of 16 to the 3rd power. I don't know what 16 to the 3rd power is. It's something big. And then we would have to take the nth root of that, which is going to be even harder. So this is just more difficult. Now, I can prove to you that they're the same, and I'll do that in just a second, but keep in mind, you can either take the nth root of the radicand and then raise that whole expression to the m power, or you can take the nth root of the radicand to the m power, and it is different, okay? So let's go to the calculator just to prove that we know that this is all true. So we're going to go, ooh, is the calculator here maybe? Yes. So we're going to go to the calculator, and first we have 16 raised to the, what was it, 2/3, 3/2 power. Well, we get 64. That's great. That's what we found. But just to prove to ourselves that this is really what's going on, we could take the square root of 16 and raise it to the 3rd power. That's what I did. I like that first because the square root of 16 is 4. 4 to the 3rd power is 64. Versus the square root of 16 to the 3rd power. We're still going to get 64, but just so you can kind of see the difference here, we've got 16 to the 3rd power. That's 4,096. That's huge. Like, most of us don't know 16 to the 3rd power. And then we certainly don't know how to find the cube root of that, right? But we can, or the square root of that. But we can go here and do the square root of 4,096 and prove that it really is 64. So hopefully by playing around with our calculator, we've proven to ourselves that either way you slice it, this really does equal 64. But just to be clear, my preference is this one right here. So this is my preference. I think this one's typically easier to work with, but it really depends on the person. Okay, let's look at part B. So part B, we have 27 to the 2/3 power. Our index is the denominator of the rational exponent, so we're dealing with a cube root. So we have the cube root of 27, and then I want to take the entire expression and square it. Now, the cube root of 27, we want one of 3 identical factors of 27. So 27 is 3 times 3 times 3. So the cube root of 27 is 3, and then we just want to square it. So that is 9. Okay, now this is going to be way harder if you did the cube root of 27 squared, because you'd first have to figure out what 27 squared was and then find the cube root of that. So again, I think this method is easier. Now, be careful when the base is negative, okay? When the base is negative, you either have the negative inside the radical or outside the radical, okay? And in part C, the negative is actually going to be outside the radical. So we have negative 16 to the 3/4 power. That negative has nothing to do with the power of 3/4 because this is really -1 times 16 to the 3/4 power. If we had had parentheses around the negative and the 16, then we couldn't undo the negative and 16. But without parentheses, the negative is a separate factor. Okay. So we get -1 times, well, my index is 4, so that tells me I have the 4th root of 16 to the 3rd power. So with 16, we're looking for one of 4 identical factors. So 16 is the same as 4 times 4. But 4 is really the same as 2 times 2. So I've got 2 times 2 and then again 2 times 2. So I've got my 4 identical factors. So the 4th root of 16 is just 2. So I've got -1 times 2 to the 3rd power. Now 2 to the 3rd power is 2 times 2, which is 4, times 2 again is 8. So I get -1 times, whoops, times 8, which is -8. So it took us a minute, but -16 without parentheses to the 3rd power is equal to -8. Okay? Now, part D, we have -64 in parentheses. Those parentheses bind the negative and the 64 together. They have to stay together, and the negative does go under the radicand. Okay? Or goes under the radical. It's part of the radicand. Okay, so my denominator is 3. That tells me my index is 3. So I'm looking for the cube root of -64. And then we want to square that whole thing. And a negative under a radical is fine as long as the index is odd. Remember, the principal nth root says if the index is odd, the radicand and the result can be negative, okay? So we want to look for 3 identical factors of 64. So 64 is really 16 times 4. 16 is 4 times 4. So we've got our 3 identical factors, and if the index is odd and the radicand is negative, so is the result. So this is really -4 squared. But now we're taking a negative and we're squaring it. So this whole thing just becomes +16. Okay? So be careful with those negative bases. Okay? Finally, we have -25 in parentheses. That means those parentheses are binding the negative and the 25 together. Outside the parentheses, we have an exponent of 5/2. So the negative goes under the radical, and I have an index of 2. So I have the square root of -25 to the 5th power. Well, this is a problem. When you have an index that is even, the radicand and result have to be non-negative. So we would have to say that this is not a real number. Can't do it. Okay. So again, just like in the previous video, be especially cautious when the base is negative. If there are no parentheses around the negative base, the negative is not part of the radicand. If there are parentheses around the negative base, the negative is part of the radicand. Okay. So keep that in mind as you're applying these two rules for exponents.